Alright, I'm going to call this part 2 of my Build a Guitar Amp series, and it's also going to be part 2 for my shop tour. So this is a dual part 2 video. I'm standing at the entrance of my wood shop, which actually pretty small. I'm just panning around here showing you the whole thing. But this is my wood shop. And this is also where I kind of put together like chassis and things like that. Any kind of construction work like that. I'll do a quick tour of it here. You come in the front door, and to my left here is my drill press. It's rather old, but it works good. As you can see, I have a couple of jigs for drilling pen blanks. Sometimes I'll get into pen making on my lathe. We'll get to that in a minute. So those are some of the jigs that we use for that. Drill bits, all those sorts of things in the back. Next is my Jet 18-inch bandsaw, and it runs on 240 volts. And right now I have a 1-inch resaw blade in there. I was doing some resawing of some maple, and actually you can see one of the pieces that I cut down from a thick piece the other day. And this is what I used to make the top. I made a replacement top cover for a Pioneer SX 750 that I just sold on eBay. I have another 750 that's on the list here to be rebuilt, so I'm going to do it one of these days too, and I'll probably do a video on that. And I'm sure that's all you guys want to see is another Pioneer restoration video. But anyhow, so there's my 18-inch bandsaw, and you can see got the big cast wheel on it and so forth. So it's pretty nice. Does a good job. I have a 13.5-inch thickness planer, and it's dual feed rate. It's pretty nice. It's 3 cutter heads, and I have it fitted right now with some aftermarket carbide cutters. Works really well. And next to that, I have the actual cabinet, which I've started to strip down to refinish for my old Philco 112 radio. And I think one of my videos you actually see where I do a little tune-up on it. It's been all restored. Now I got to do the cabinet, but that's down on the list. I got so many other things. Behind that is my dust collection system, and it's a Laguna. It's pretty nice, and it has the cartridge filter on it, and the flour goes down there in that bag down there in the bottom, and the actual wood chips go into this barrel here, which we empty out with the bag, and that kind of picks up the dust on all my bigger shop equipment. Over here you see my clamps and my saw blades and some of my router bits. And then you move around this way, and this is my chisels and planes and saws, hand tools. This is basically my hand tool rack that I made. More tools down in there. We move over from there, and there's my joiner, and it's a rigid. I've had it for a very long time. It works really good. I don't even know if they make this model. If they do, it's a little different now. But 6 1/8 or 6 1/4 inch joiner. Again, more saws, more, I have a jig for, a miter jig for the table saw. Screws and storage and hardware and every kind of thing you can think of here. Moving right along. Down here I have, it's just kind of sitting there temporarily, is my mortising machine for doing mortises. If anybody doesn't know what a mortiser is, it's basically, as you can see this bit down here, it's for cutting square holes. There's a drill bit that runs down through the middle of it. You can kind of see. And that drill bit clears out the center of it, and then the square chisel cuts out the square holes, and that's for making mortise joints, which are like a square, tab A and slot B sort of thing for woodworking. Behind that is a very complicated, hard to use dovetail jig made by a company called Lee, and makes really nice dovetails. You can make custom dovetails any size, any shape you want with this. So it's a pretty good device once you learn how to use it. Dust masks and safety goggles, all that good stuff. You got to have that. Over here's a fret press. I do some guitar making. You can see a couple of necks that I've built over the years. Here's one. You can see. And then here's another one I've started. You can see it along here. I'm not going to dig it out right now. So do some guitar work. Here's a couple of pen blanks that I drilled out with that drill press that you saw. And I glued the brass tubes in them. Maybe one day we'll do a video on how to make a pen. I know there's lots of people that have videos on it. And my little Delta mini lathe. And for what I do, and I have the extension bed on it, and for the kind of turning that I do, it's more than adequate. I don't do bowls or great big things. I just do spindle turning and things like that. A bunch of power hand tools down here, sanders and nailers and jigsaws, things like that. Over here's my compressor, air compressor, and some more hand power tools. Over here's my sharpening station, and I have a work sharp, and I have one of these with the silicon carbide, and then I have the actual attachments for doing the, they attach down in here and in here, and those are for doing the chisels for the lathe turning tools for sharpening them, because you need special jigs to really sharpen them properly. And some clamps, and here it also is integrated into my little chop saw station that I made. And a limited space, so the longest I can cut from the blade to here is 5 feet, okay, 60 inches, but that's enough for most of what I make. I don't try not to make big projects. Keep all my glues and adhesives and miscellaneous things here. Here's a guitar body that I've made, and haven't finished it up yet. I got to fit the neck to it and do all that. One of these days we'll get to it. All right, a drum sander slash spindle sander, belt sander thing for sanding. Over here is my workbench, and I made this workbench myself, and it's made out of this is solid oak, and it's about 3.5 inches thick oak, and it's banded with a special kind of African hardwood called Purple Heart, and big heavy oak legs on it, you can see. And this is kind of where I make all my messes of woodwork. Next to that is my table saw, and I have a Powermatic 2000, and this is one of my favorite things I have in my shop here, you can see. And very nice table saw, very heavy duty cast iron trunnion system in it, and 240 volt single phase 3 horsepower motor, real big. Moving over here is my this is my router table, and it's got a top adjustable router, so you can put the little crank in there, and you can move the router bit up and down. You can even change the bit above the table. So I put all this together. And inside here I just keep all my routers and so forth. I have several routers. Every woodworker loves his routers. It's just one of those things. So that's pretty much the shop. That's it. Not very big, pretty cramped space. But hey, make do with what you have. So really the real reason I'm down here is to go over, I told you I was going to show you a simple way. And sorry about the camera, I'm walking around, I'm doing handheld camera today. But today I was going to kind of show you here how I made up this chassis for our guitar amp project. And really it's very simple. You can go to your hardware stores and you can buy, you know, sheet stock aluminum like this, okay? And if you buy it at the right place, you go to the surplus stores and so forth, you might be able to get a piece like this relatively inexpensively. And then if you go to Harbor Freight or go to one of those places, you don't need to spend a lot of money. Buy a pair of these shears, or you could just use a set of, you know, regular hand cutters, you know, tin snips. But this works really well, and you can run this along a straight edge and actually get a pretty straight cut. Okay? And so all you do is you just cut down your piece of aluminum how you want it. And then all you need is like a nice squared off edge, like the edge of this bench, the edge of the table saw, something like that. And you just take your aluminum and you just make 2 bends in it, you know, for your 2 sides. Then you cut a block, 2 blocks of wood, and you put them in the sides like that. And this is going to be for if you did like a combo amplifier, which is what I'm going to do. We're going to build a cabinet for our guitar amplifier to house the speaker and the amp and everything. And this wood gives us something to screw into from the sides. The actual amp will be like this, so your controls will be across the top. Our tubes will be out the bottom. Our transformer would be on the back here. And the circuitry will be here and it'll be facing you. And the back cover of the guitar amplifier will cover that up when you put it on. And then the bottom part of the back will be left open, an open back type thing for the speaker. Okay, so it's real simple. This is it. This is how we're going to build our amp. Now I brought this transformer down here because it's really ratty, as you could tell. It's been painted and it's gotten dirty. So I'm going to take the bells off of this while I'm down here today. And I'm going to just strip these off. I might put them in some paint stripper or maybe hit it with a wire brush or something. And then paint it back up, make it look nice, and put it back together. And so that's where I am with my project right now. I just thought you'd be interested in all of this. And I'm going to bring this up to the electronics shop. And we're going to start punching it out once we design our amp. Okay, so we're going to do our schematic next and then show our layout, kind of figure out how we're going to lay this out from there. So again, thank you for this, for coming along here for the short tour, and more to come later. Okay, I'm not going to end the video here. I thought I was looking at a comment that I had on the last video we had for the guitar amp, and there was a little bit of confusion about when I was talking about the output transformers. Now this is a dinky little, out of a radio, just a small single-ended transformer with a single tap. But I wanted to do a little online demonstration here. Excuse me. Sorry, I had a call from work there. Anyhow, so what I want to do here is I want to kind of clear the air a little bit about these transformers and how they work. Something that I forgot was I was going to actually print out a wiring diagram for one of those universal output transformers that has multiple primary and multiple secondary taps. And what you would see is that depending on what secondary tap you use with what impedance of speaker you connect to it, it will affect what the primary taps show as a primary impedance. Now, this is certainly not a perfect experiment that I'm going to show you, but I think it will prove the concept to you and give you a little bit of an understanding of how everything affects everything else. So the first thing I'm going to do is talk about meters for a second. I have two different types of ohm meters here. Okay, so the first one is your basic fluke, 187 multimeter. And if I set it to ohms, it will actually measure the DC resistance of whatever you connect the leads to. So for instance, I connect this little teeny tiny speaker, and if you look, DC resistance on that coil is 13.65 ohms. Okay, so this is probably like a 16 ohm voice coil speaker. This one, it says right on it, 8 ohms. Okay, and if I connect this up, 10 ohms. Okay, how does that work? I thought that everybody's always said that, an 8 ohm speaker should read about 6 ohms. Well, that's not always the case. There's a lot of other factors that it involved based on the winding length of the coil, the diameter of the coil, the thickness of the wire, the size of the magnet. So many things can affect the static resistance, okay, the DC resistance of that coil. This big organ speaker, which we're going to actually use for our guitar project, is supposed to be an 8 ohm speaker. We look at its DC resistance and it's 9 ohms. So it's a little bit higher than 8 ohms. And this one here is a coaxial speaker. It's very modern. You'd see, in ceilings and things like that. And it's only about 6 ohms. But it is actually supposed to be an 8 ohm speaker. Alright? Now, here's where it gets interesting. And that is, that would be the DC resistance. What this LCR meter will do is it will allow us to read the impedance. Or really, it will allow us to read the resistance with an AC signal applied. And we can choose 5 different signals. We can choose 100 hertz, 120 hertz, 1 kilohertz, which is where we're set to now, 10 kilohertz, and 100 kilohertz. So at those 5 different frequencies, we can actually measure the impedance or the resistance, okay, at that particular frequency. So let's do that, and you'll hear this thing going through its test as you hook it up to the speaker. So let's start with this little one to begin with. Okay, we'll do this one first. Okay. You hear that? Pretty quiet, but you can hear it. And if you look at 1 kilohertz, that speaker was reading a little different, but now it's reading 10.5 ohms, right? So at 1 kilohertz, it's a 10 ohm, puts a 10 ohm load at that resistance. Now if I go back to DC resistance, what did we read? I'm not writing any of this down. DC resistance was very similar, 10.5. So it doesn't really change a whole lot. Now, that said, this tiny little speaker, remember it was about 14 ohms, 13.6. If we connect our LCR meter to that, and you can see about 14 ohms, okay? It's very similar. And this one was reading what, about 7 ohms, I think it was. About 6.7. It's pretty close. And if we go to our big speaker, you hear how loud that one is? And it's 11 ohms. Okay, so they're all pretty close at 1 kilohertz. Okay, now the reason I did that is now we're going to do the same test. And hold on, let me scroll through. And we're going to do this next one at 10 kilohertz. Now, you may hear it on the microphone, you may not. And you can see it's 12 ohms. All right, so the resistance has changed a little bit. And if I change down to 100 kilohertz, look at that. It goes up to 24 ohms. And if I go down to 100 hertz, about 10 ohms. All right, back to 1 kilohertz, 10 ohms. All right. So what we're saying is that the resistance can change with frequency and from speaker to speaker, even though they may be rated all at 8 ohms. Okay, they may present a different load, and that would even change even more if you increase the power. Now again, this can't put enough voltage out to actually move the speaker a whole lot and cause other things to happen, but it is a reactance. This is not a static resistance. That's the point that I'm trying to make. And the reason I'm saying that is you have that taking place at the end of this transformer. And if we ring out this transformer at 1 kilohertz, okay, you'll see it reads about 70 ohms, okay, with nothing on the load. Now, compare that to our DC resistance. Is only 5 ohms, okay? So you can see frequency, because this is an inductor. That's what a transformer is. It's an inductive load. It changes with frequency, okay? So from 5 ohms, we apply that a signal of 1 kilohertz to it, and all of a sudden it's giving you an equivalent of 70 ohms. All right, now here's where it gets interesting. If I short these together, that puts a no load on it, and look what happens. The resistance on the other side effectively drops to 7.7 ohms. Okay, now if I put a speaker on it, okay, and this will be an 8 ohm speaker, all right, you can see that the resistance changes. It drops to about 27 ohms. All right. If I connect it to the 16 ohm little tiny speaker, it's 35 ohms. So depending on what load we put on the output, and again, this circuit is easy to load down. This signal coming out of this meter doesn't have much current, so it does skew the readings a little bit. But again, like I said in the beginning, proof of concept, by varying the load on this, it effectively changes the presented load on the primary. So I had somebody make a comment that shouldn't that yellow lead on that transformer be considered the 16 ohm lead? And the answer was yes, because when they rate an output transformer, what they're trying to do is they're saying that this will remain, the primary resistance will remain the same as long as you put 8 ohms on these leads and 16 ohms on these leads. This will always stay the same. Okay, so he was right in his question. But what I was trying to show in that last video was when you use a transformer that isn't exactly designed for the application you want, you can experiment, and by knowing that impedance ratio, you can roughly calculate, okay, by putting that 8 ohm load on taps that weren't originally designed for 8 ohms, it would create a different plate load on this end. It would change the impedance on this end, just like we saw here when we changed the loads on this. And you could use that to adjust it to a plate resistance that would match the particular tube you're trying to use. So for instance, that original transformer was probably an 8K transformer, 8 kilo ohm transformer for two 6BQ5s, 8K plate to plate. And if you had an 8 ohm speaker and you connected it to the green lead, you would get an 8K plate to plate load. And if you had a 16 ohm speaker and connected it to the yellow lead, you would still get an 8K plate to plate resistance. But if we used the two outside leads and we used an 8 ohm load on what was originally designed as the 16 ohm tap, we find, lo and behold, that it would bring it within range of our 6550 tube in single-ended mode that we wanted. Okay, and that's, I think, what I was trying to get across, was that you can actually use a transformer that wasn't originally designed for that particular tube, as long as you know the impedance ratio and as long as you know what taps to put what load on. Again, that is how a universal output transformer works. In other words, that output transformer may have 4 or 5 wires on the secondary, and each wire can have a different impedance based on what plate load you're trying to get on the primary. And that it comes with a little paper chart that says connect, for 8 ohms, connect to these 2 wires and connect to these 2 wires on the primary with your tubes, and this will give you 8 ohms output and X amount of ohms on your plate load. Okay, so that's how they work. And all I did was kind of come up with my own little chart for that particular transformer. So I hope that helps you understand a little bit. Maybe I just confused everybody more, I'm not sure. But essentially what I'm saying is that the purpose of building this guitar amp is to try to use what we have and try to make it work for what we've got. And by doing this, this allows us to come up with our numbers and make them work. Okay? Now it's very important to match the plate load to the speaker load, or you could cause the tube to draw excessive current, because obviously it's Ohm's law. If the resistance drops too much on the transformer, then it has to go somewhere. The current has to go somewhere, so it's going to go into the speaker. So by increasing the current through the transformer, it's increasing it through the speaker. By lowering the overall resistance, the tube, I'm sorry, and you're overloading the plate of the tube, and by overloading the plate of the tube, you may damage the tube. So that's why you want to try to match it. But anyhow, I hope this made it a little more understanding, and instead of less understanding. The only other thing I'd like to do here real quick, I'll just for comparison, is show you that get back into resistance mode. If I go back to my standard ohm meter here and I grab these 2 wires, this goes up to my resistors, okay? And those are just my dummy loads. Now this is supposedly a non-inductive resistor, okay? So it's 8 ohm non-inductive. And if we measure it here, I'm getting about 10 ohms. And the reason I'm getting 10 ohms is because I'm going through all these leads and connector plugs, and I have switches in there and so forth. So it adds a little bit of DC resistance. But just make sure you look at that number, 10.7, okay? Now, If I connect this up, about 10.5 ohms. And if I change, no matter what frequency I go to, here's 10 kilohertz, it's still 10.5. 100 kilohertz, still about 10.5, a little bit higher, not much. If I go down to 100 ohm, or 100 hertz, 10.5 ohms. 120 hertz, 10.5 ohms. So that's the difference between an inductive load and a non-inductive load. So that's why when we test an amplifier on the dummy load, we have a constant that we're measuring against. No matter what frequency we apply to that resistor, it's always going to present an 8 ohm load to the amplifier. Whereas if we were to connect one of these speakers while we were testing an amplifier, it would vary. The impedance would vary, so therefore the power would vary with frequency, and so you wouldn't get as accurate as a measurement as what you're trying to do. So just for comparison's sake. So I hope that doesn't confuse you guys, and I hope I hope you understand where I'm coming from on that. But that's at least what I meant to get across to everybody when I did that first thing with the impedance ratio of the transformer. Alright, so again, let me know if that makes sense. Let me know how I could have reworded it to make it make a little more sense, because again, I'm not perfect at all this stuff, but just try to share with you whatever I know. I just see more and more kids out there today that don't take interest in any of these things anymore. They they kind of get their nose into their video games and so forth, and they waste all of that talent and ability on playing the game rather than learning how the game was built. And I think they're missing out on something. So when you guys watch these videos, if I can teach you something and it can inspire you to go out and do some things and keep this kind of art going on and keep this hobby going on, then it's worth it for me to spend my time doing this. So alright guys, that's it, and this time I'm going to end this video for sure. I'm getting long-winded on you, I apologize, and more to come later.